Hello everyone, Aaron here and welcome back to Leetcode. Today we're doing the same tree problem. Given the roots of two binary trees p and q, write a function to check if they are the same or not. Two binary trees are considered the same if they are structurally identical and the nodes have the same value. So for example, here we see these 2's are the same, these 1's are the same, and these 3's are the same. Here we see, although the 1's and the 2's are both the same, the 2 is to the left of the 1, and here the 2 is to the right of the 1. Their in-order traversals would be identical, but the trees themselves are not. And here we have 2, 1, 1 and 1, 1, 2. They are mirrors of one another, but they are not the same. So, this puzzle is a great way to get introduced to recursive thinking. So one way to think about it is, what is the easiest tree to decide if they're the same? You might think, well, that's a single node, but in fact there's an easier tree to decide if they're the same, and that is a completely empty tree. So if p is none and q is none, return true. That is the easiest way to tell if two trees are identical. Then we have to think recursively. I don't know how to tell if these two trees are the same or not. However, if these two trees are the same, then their nodes, their values match at the root, and the left tree matches this left tree, and this right tree matches this right tree. So we want to return p.val equals q.val. That's the current nodes are the same, and self.is_same tree, p.left q.left, and self.is_same tree, p.right q.right. So let's just quickly space this out a little bit to be slightly less gross to look at. Now, this is not quite going to work off the top, but it's very, very close. So let's think about what we've actually written here. We've said two trees are the same if they're both empty trees. Easy case. Otherwise, we need to check the node we're currently looking at is the same, and the left subtrees match, and the right subtrees match. Now, I've asserted that this isn't going to work as it currently stands. Pause the video if you don't know why. If you've thought about it and do know why, excellent. The trick is, we've here assumed that they're of the same shape. But the whole point is we're checking they're the same shape. And the problem occurs if p is none or q is none. If one of these is none but the other isn't, we're not going to be able to do this .val business. That's going to just straight up break. So we need to check that first and say if p is none or q is none, return false. If one of them is none but not the other, they're different shapes. The check we're doing, the reason we don't need to check that p is none and q is none, that's okay, but we've already handled that case. We will never actually do this check if we've already asserted they are both none. So this check is only for if one of them is none. And then finally this case here checks that their structure is the same. So let's run that. Ding, dong, ding, ding, ding. There we go. True, true. Excellent, that's fine. False, false. Perfect. False, false. Perfect. Python's actually a pretty bad language for expressing this. So if we were working in something like I don't know, let's say something like standard ML, which is a bit of an odd language, but it's similar to Haskell. So if you had a data type tree is equal to leaf or branch of int tree. You could do something like saying fun is same tree. They're both leaves. That's true. And is same tree branch. Hang on, I need to do this slightly differently. Branch VLR branch V prime L prime R prime. That's where you want to say this is true if V is V prime and also is same tree L prime and also is same tree R prime. And in every other case, it's false. So let me just tidy that up a wee bit. So if you've never seen standard ML before, this might look a little strange, but the general idea is a very direct translation of exactly what we want. If they're both leaves, great. If they're both a branching structure, we want to check that their values are the same, that their left sides are the same and their right sides are the same. And in every other case, we want to say it's false. That's very much what we've set up here, but we've had to be a little more careful about these particular cases. So a functional language makes this kind of expression very easy, and it's not too bad in Python either. Right, let's submit it, make sure we've got it correct. It's looking good, it's just taking a while to load. There we go, perfect. So we're very much middle of the pack here. Our memory is, well, it doesn't look like there's too many options in terms of memory. You get lucky or you don't. That's really all there is to this one. One interesting challenge might be to try and do this without using recursion. The recursive solution is incredibly natural here. But there are other ways to do it. You might like to try and do some stack operations like we did in yesterday's video, where we solved a very naturally recursive problem of traversing a tree, but we did it without using recursion. Could you do that here? Anyway, I'm going to stop rambling now. I've solved the problem twice over. You're sick of hearing me today. That's going to be it from me. Do remember to like, comment, subscribe, all of that good stuff. How did you do it? Do let me know. And I will see you next time. Bye.